Morning all, I am Mahin Fatima studying CSM in Srinivas Ramanujan Institute of Technology. My chemistry assignment topic is synthesis and applications of conducting polymers. Let's go into the topic. First, let me explain the outline: polymer, conducting polymers, chemical structure, classification of conducting polymers, synthesis and mechanism of conducting polymers, p-doping, n-doping, applications and conclusion. Next, polymers. First, what is meant by polymer? The word polymer derived from two Greek words. Poly means many and meros means part or unit. Polymer is formed by combination of small molecules. Polymers are poor conductors of electricity and generally used as electric insulators and dielectric materials. Next, conducting polymers. An organic polymer with highly delocalized pi electron system having electrical conductance on par with metallic conductor is called a conducting polymer. For example, polyacetylene, polythiophene, polyphenylene, polyaniline. Next, chemical structure of some conducting polymers. Like I have taken some conducting polymers. First, polyacetylene, followed by polyphenylene, followed by polypyrrole, followed by polythiophene, followed by polyaniline, followed by polyphenylene. These are the chemical structures of some conducting polymers. Next, classification of conducting polymers. Conducting polymers are basically divided into two types: intrinsic conducting polymers and extrinsic conducting polymers. Intrinsic conducting polymers are again divided into two types: doped conducting polymer and conductors with conjugation. Extrinsic conducting polymers are again divided into two types: conducting element filled polymer and blended conducting polymer. Doped conducting polymers are two types: p-doping and n-doping. P-doping is nothing but positive doping, n is negative doping. Next, synthesis or mechanism of conducting polymers. The conducting polymers like polyacetylene and polyaniline can be synthesized by doping, in which charged species are introduced in organic polymers having pi electron backbone. Next, positive doping. In this process, an intrinsically conducting polymer or conjugate pi electron conducting polymer is treating with Lewis acid. Then oxidation takes place and creates positive charged sites on polymer background, such as current carriers for conduction. Let us see p-doping with an example. I have taken acetylene C2H2 taken whole n plus 2 FeCl3 gives rise to C2H2 plus NFeCl4 minus plus FeCl2. Again, 2 C2H2 taken n plus 3I2 gives rise to 2 C2H2 plus I3 minus. Here C2H2 is acetylene. If we take whole C2H2, it is polyacetylene. Mechanism of conducting polymer of polyacetylene. See, in polyacetylene, first polyacetylene is reacted with iodine in the presence of carbon tetrachloride. Here oxidation takes place and electron is lost. We get the compound polaran or polar. Again, it is reacted with iodine in the presence of carbon tetrachloride. It is second oxidation. We get bipolaran. Here in bipolaran, 2 electrons are lost, so we get bipolaran compound. Now the combination of above two radicals, we get the required structure. Next, negative doping. In this process, the conjugated pi electron or trading with Lewis base. Then reduction takes place and creates negatively charged sites on polymer backbone, which are responsible for the conduction. Some of general N-dopants used are lithium, sodium, calcium, and tetrabutyl ammonium. I have taken one example for N-doping. The same conducting polymer polyacetylene, it is reacted with sodium C10H8. Here reduction takes place and creates negative charge on the polymer. We get polaran. Again it is reacted with Lewis base like sodium C10H8. Electron is lost, so we get negative charge. As reduction takes place, we get bipolaran or bipolar structure. Next, applications of conducting polymers. Conducting polymers are used in solar cell, in photovoltaic cell, non-linear optical materials, telecommunications, in membrane for gas separation, chromatography. It is used as antiseptic coating for charging. Next, it is used in ion exchange gases, rechargeable batteries, and so on. Next, conclusion. Conducting polymers have been widely used in biomedical applications due to their high conductivity, compatibility, and low cost. These conditions of conducting polymers make more attractive to bioengineering students and also scientists. Thank you for giving me this wonderful opportunity. I hope you found this video insightful.